Hello, in this video we're going to go through learning target 323, which is the characteristics of polynomial graphs. And in this one we're going to talk about these 5 characteristics, and then in another video we'll go through just domain and range. So the first thing we're going to talk about is end behavior. And we have this kind of like template for end behavior that has 2 parts. And if you read this, it says, as x approaches infinity, f of x, which is y, approaches blank. And what it's saying is that as x approaches infinity, that means as I go to the right, so toward infinity is to the right, where is our graph going? So is it going to go up or down? Those are really your only 2 choices. And your second sentence says the same thing, except we're going toward negative infinity, which is left. So if your graph goes up, it is toward positive infinity, and if it goes down, it is toward negative infinity. Kind of related to that is whether our polynomial is an even or an odd degree. An odd degree means that the ends go in opposite directions. So I remember that because odd and opposite start with the same letter. And even, the ends go in the same direction. Pause it if you need to get that down, but I'm going to go down to the example and talk about how to find these 2 characteristics. So here's our polynomial, and it says find all these characteristics, and we start with end behavior and whether our polynomial is even or odd. So end behavior, this first sentence says as x approaches infinity, which means it's asking me about the right side of the graph. Where does our graph go? So as I go to the right, my polynomial goes up forever, so that is positive infinity. And then it says as x approaches negative infinity, which means as we go to the left, our graph goes down, which is toward negative infinity. And since our ends go in opposite directions, one goes down, one goes up, our polynomial is odd. So now let's look at these other 3 characteristics. One is about the maxima and minima, and then the other is about the zeros. So maxima and minima are just the plural ways to say maximum and minimum. And collectively, they are also called extrema. So if I ask you about all the maxima, that's all of the maximum values. If I ask you about all the minima, that's all the minimum values. And if I ask you about the extrema, it's talking about both. Now there are 2 types of maxima and minima. One is a local and relative, and the other is absolute. Local or relative maxima or minima are only when compared to the immediate area. So it's a maximum or a minimum, but only when compared to like the area just around it. And then absolute would be compared to the entire graph. The only thing you really need to be careful about with absolute is that we need to pay attention to the arrows. Pause it if you need to get that down. Looking at our example, we are asked about the local maxima and local minima for our polynomial. And so local maxima, I just kind of think of those as like the tops of hills. So I'm kind of just like walking along this polynomial, and anytime I reach the top of a hill, that is in fact a max. Anytime I reach the bottom of a valley, that is a min. Max and min. And I'm just going to pull these values over for my local maxima and local minima. So I should have 2 of each written as points. And then we want to look for any absolute extrema. So this question asks for if there's any absolute extrema. If it is, then identify them. So what I'm looking for is like the very, very top the polynomial will ever go and the very bottom. So when I do that, I first look to see if there's any arrows. And in fact, there's an arrow pointing up, which means I cannot have an absolute max because I'm going to keep going up forever. There's also an arrow pointing down, which means I can't have an absolute min because I'm going to go down forever. So are there absolute extrema? That answer is no. If there was a highest or lowest point, you would just write it there. And our last characteristic is our real zeros, which are our x-intercepts, just like last unit. We're just going to have more of them. So our real zeros, I just kind of go along my polynomial, and every time I touch the x-axis, that is a real zero. And so we're going to write all these as coordinate points. There are 5 of them. Some of them are decimals, so just make sure that you estimate as close as you can. This first one is probably like negative 4.2. The next one is negative 2. The next one is 0.9-ish. The next one is 4. Oh, wait. 2, 3, I mean. Sorry. And our final one is 4.6-ish. And this is how you find all of those characteristics for the polynomial. So what I want you to do is pause the video, do the U-try on the next page, and then unpause so you can see the answer. Here are your answers for your U-try. So you should have positive infinity for your end behavior because both ends go up, which means it is even. Your local maximum is right here at 0.4. You have 2 local minima down here. And then those are also the absolute extrema because this is the lowest this graph will ever go. And those are tied. So they're both the absolute. And then you should have 4 real zeros all written there. Hope this helps.